abort one or more processes to break the circular wait. The other to preempt some resources from one or more of the deadlock processes. Okay, the first action, process termination. To eliminate deadlocks by aborting a process, we use one of two methods. In both methods, the system reclaims all resources allocated to the terminated processes. Abort all deadlocked processes. This method clearly will break the deadlock cycle, but at great expense. The deadlocked processes may have computed for a long time, and the results of these partial computations must be discarded, and probably will have to be recomputed later. But this way is easier to realize. The second way, about one process at a time until the deadlock cycle is eliminated. This method incurs considerable overhead, since after each process is aborted, a deadlock detection algorithm must be invoked to determine whether any processes are still deadlocked. Aborting a process may not be easy. If the process was in the midst of updating a file, terminating it will leave that file in an incorrect state. Similarly, if the process was in the midst of printing data on a printer, the system must reset printer to a correct state before printing the next job. If the partial termination method is used, then we must determine which deadlock process should be terminated. This determination is a policy decision, similar to CPU scheduling decisions. We should abort those processes whose termination will incur the minimum cost. Unfortunately, the term minimum cost is not a precise one. Many factors may affect which process is chosen, including the priority of the process, how long process has computed, and how much longer to completion, how many resources the process has used, how many more resources process will need to complete, how many processes will need to be terminated. Is process interactive or batch? Of course, comparing with interactive process, the batch process is selected as victim first. Okay. Resource preemption. To eliminate deadlock using resource preemption, we successively preempt some resources from processes and give these resources to other processes until the deadlock cycle is broken. If preemption is required to deal with deadlocks, then three issues need to be addressed. First, selecting a victim. Which resources and which processes are to be preempted? As in process termination, we must determine the order of preemption to minimize cost. Cost factors may include such parameters as the number of resources a deadlock process is holding, and the amount of time to process has thus far consumed. Rollback. If we preempt a resource from a process, what should be done with that process? Clearly, it cannot continue with its normal execution. It is missing some needed resource. We must roll back the process to some safe state and restart it from that state. So the system has to record the safe state for each process. Okay. Since in general it is difficult to determine what a safe state is, the simplest solution is a total rollback. Abort process and then restart it. Although it is more effective to roll back the process only as far as necessary to break the deadlock, this method requires the system to keep more information about the state of all running processes. Starvation. How do we ensure that starvation will not occur? That is, how can we guarantee that resources will not always be preempted from the same process? In a system where victim selection is based primarily on cost factors, it may happen that the same process is always picked as a victim. As a result, this process never completes its designated task, a starvation situation any practical system must address. Clearly, we must ensure that a process can be picked as a victim only a finite number of times. The most common solution is to include the number of rollbacks in the cost factor.